Hello to all of you. So in previous lecture we discussed about non-alluvial channel. Clear? So in this lecture we discussed new design method of alluvial channel. So design of alluvial channel. Clear? So what is the alluvial channel? Which is excavated in alluvial soil. So what is the alluvial soil? That called silt. And in this velocity is high. Clear? So velocity higher, so no scouring will occur and velocity in most of the cases alluvial channel when the velocity is high so scouring will be occur, but in the velocity is low so that deposition or silting will occur. So that channel designed according to non-scouring velocity and non-silting velocity. Clear? So according to that there are two theories to used for design of alluvial channel. So there are two theories which is very important that called Kennedy's theory and second one Lee's design theory. So first one we discuss about Kennedy's theory. So Kennedy theory is based on the upper Barry Dobb canal system. Clear? So the Kennedy selected the channel which is not require silt clearance for more than 30 years. So it is based on first one upper Barry Dock canal system. That channel not required silt clearance for more than 30 years. So what are the conclusion as per Kennedy? So first conclusion is that flowing water experience friction against the canal bed width which causes eddies on the surface. Means the water will flow on the directions so that some frictions are generated and that due to that friction which produce eddies means one type of small wave on the surface. Clear? So these eddies are responsible to keep that particular silt in the suspension, means moving condition. Hence, the bad weight is proportional to the silt supporting power. Here, remember that bad weight is proportional to the silt supporting power. So, all in all, silt supporting power is proportional to bad weight. Then second one, critical velocity. They give a velocity of critical velocity, mean velocity which keeps the channel free from silting and scouring. Here, so that called mean velocity which is VO. The formula for that VO equals to 0.55 and into d raised to 0.64. Sorry, VO 0.55 d raised to 0.64. Clear? So which can be written in this type of form VO 0.55 d raised to n. So what is the VO? That called critical velocity. D means depth, C means constant, and equals to index number. Then after Kennedy realized that particular sand haves or sandy silt have that particular part in that design. So that conclude M factor. Clear? So what is the M? That called a critical velocity ratio. Then so the new formula which is VO equals to 0.55 M into D raised to 0.64. So M equals to CVR, that called critical velocity ratio, which is V upon VO, means V equals to actual velocity divided by critical velocity. Then third conclusion is that silt grade means silt size finer at the upper Barry Dobb system, which is range 0.8 to 0.5, and for coarser 1.1 to 1.5. And there are three conclusions which is given by Kennedy. Done. And the Kennedy used the formula to find out velocity. That formula called Cutter equations. Here Cutter's equation, which is that given V equals to 23 plus 1 by n plus 0.00155 divided by s divided by 1 plus bracket 23 plus 0.00155 divided by s bracket over n upon under root r into under root rs. Clear? So this is all r, which is I said that 23 like this. This is a constant that called c under root rs. Clear? And what are the meaning of and that called rugosity coefficient, which depends on the boundary material. If the surface is very bad, so the n equals to higher. Clear? Vice versa. So this is the theory of Kennedy. Here there are three points in conclusion, and they use Cutter's equation to find out velocity. It is based on upper Barry Dobb canal system, and that site require that site not require site silt clearance for more than 30 years. Clear? Please remember this formula V equals to 0.55 m into d raised to 0.64 and Cutter's equation. Clear? There are design procedure. There are two cases which is given. So that case one, the data is given Q and M and S. Clear? In this example or in exam, they did they did not define that example on the basis of Kennedy. You can recognize by the data which is given. In this, Q is given, and means rugosity coefficient is given, M is given, means CVR is given, and bad slope is given. So what is the step one? So in step one, first of all, you assume that particular depth which is near about range 2. Clear? Otherwise, we can say that 1.72 or 2.3. This is a range to assume D. Then second step to calculate velocity from Kennedy's equation. So what is the formula of Kennedy's equation? V equals to 0.55 m into d raised to 0.64. Then after step 3, calculate area equals to Q upon velocity. Then we have a calculate step 4. Calculate B from area's formula, which is BAB plus ND square. Clear? And if the side slope is not given, so you can consider n equals to 1/2 or 0.5. Clear? So the formula will be BD plus D square by 2. Then next step, calculate wetted perimeter hydraulic mean depth. So the formula P equals to B plus 2D under root M1 plus N square R equals to A by P. Then last step, determine velocity V equals to C under root RS from that formula. If that velocity according to the mean velocity and that Kennedy's equation which is same, so the design will be okay. But if that not same, so you can change the depth according to that, like this. If there are no change, if Vk less than Vc, so you can increase depth which you assume. If Vk greater than Vc, means Vk means Kennedy's velocity and Vc means that chase's velocity. If Vk greater than Vc, so you can decrease that D which you assume. Clear? So this is a design procedure for case 1. This is an example for case 1. Design irrigation channel by Kennedy's theory. Here is given by Kennedy's theory. Clear? To carry a discharge 15 cumac, assume n equals to this, n equals to 1. And side slope, bed slope is given 1 in 500. Here is not side or side slope is given, so you can choose n equals to 0.5. So first of all, what is the step 1? In step 1, D equals to 1.75 VSU. And what is the formula for Kennedy? V equals to 0.555 m into D raised to 0.64. So we have m, we have D. So put in this equation, so we get 0.79 meter per second. That equation or that value called A. The next step 3. Then find out cross section area. We have velocity, we have discharge, so you can easily find out area. Then step 4, we have the formula of area equals to BD plus ND square, and here is not given the side slope, so we can assume n equals to 0.5. Then so we have area put in these equations and we have depth, so we get B equals to 9.98 meter. Then after step 5, find out wetted perimeter and hydraulic mean depth. So formula is given P equals to BD, B plus 2D under root 1 plus N square. So N equals to 1/2. So we get new formula P equals to B plus D under root 5. Then we have value of D. So put in this equation. So we get P. So we get R equals to A by P. We have area, we have perimeter. So we get R equals to 1.37 meter. So then next step to find out velocity. So we have the formula to find out Cutter's equations for velocity. V equals to 23 plus 1 by n plus 1.00 155 divided by s divide 1 plus bracket 23 plus 0.00 155 divided by s bracket over n1 under root r into r into s. So we have all this value, rugosity coefficient and bed slope is given. So put in these equations. Clear? So we get 0.78 meter per second. So here in this area, oh sorry, first equation that velocity, mean velocity 0.79, here 0.78. So the value of A and B approximately same. So the assumed depth B is correct. Clear? Then second case, design procedure for case 2 of our Kennedy's theory. The discharge is given, N is given, M is given, and the V by D ratio is given. Clear? So in this example, they directly given V by D ratio, but they did not, they don't identify or they don't give any hint to this example on the basis of Kennedy's theory. So how can you recognize? So first of all, you can see that V by D ratio in that particular example's value. So you can uh, calculate that example on the basis of Kennedy's case 2. Clear? So there are total 5 steps in this design procedure. First of all, you calculate area. So B by D ratio is given. So B by D equals to like something X. So B equals to D into X. So we have the formula of A, BD plus D square by 2. So put in these equations. So A equals to dx into D plus D square by 2. So D square take common, X plus 0.5. So that equation called 1. The next step 2. So here find out depth. Discharge is given. So what is the formula of discharge? Q equals to area into velocity. So we have area and we have velocity. So what is the formula of Kennedy's velocity? So 0.55 m into d raised to 0.64, and we have area in the terms of d. So put in these equations so we can find out d. Clear? So in this method, you aware about that particular calculator function. Then the next step 3, knowing we have know the value of d, and according to that we find out b and r. So what is the formula of r? A by p, bd plus d square by 2, and divided by b plus d under root 5. So we get r. Clear? So we have value of d. So put in these equations of in the area form. So we get clear. Then step 4, determine Kennedy's velocity 0.55 m into d raised to 0.64, and the next step, determine slope from Cutter's equation by trial and error method. Clear? So this is a design procedure of case 2 when d by d ratio is given. So this is an example. Then you can understand what is the design procedure. So value of discharge is given 5 cubic, m equals to 1, n equals to 0.225 which is given. Clear? And d by d equals to 4.40. So what are the solutions? So step 1, b by d ratio is given. So you can subject d equals to 4.4 into. So the formula of area equals to bd plus d square by 2. So you can put this value b in the form of area. So we get a equals to 4.4 d into bracket over d plus d square by 2. So we get area in the terms of d, 4.9 d square, that equation called 1. Then step 2, find out dimensions. So q equals to area into velocity. Done. So what are the formula of area, which is in equation 1, and what are the formula of velocity as per Kennedy's? 0.55 m into d raised to 0.64. So we have value of m, clear, and we have the value of discharge, which is 5, clear. So put in this equation. So 5 equals to 0.55, m equals to 1 into d raised to 0.64, d square into 4.9. Then we already get easily get d equals to 1.26 meter. So putting this equation or value equals to b equals to 4.40 into d. So we get b equals to 5.4 meter. The next step 3, area equals to 4.9 d square. So we get area, and what is the formula of perimeter? B plus d under root 5. Clear? So we have the value of b and d. So we can find out P 8.36 meter, and by the area and by the perimeter we easily find out hydraulic mean depth, which is R equals to A by P, which is 0.93 meter. The next step 4, to find out velocity as per Kennedy's theory. So V equals to 0.64 meter per second. The next step to find out bed slope. Clear? Please give attention on that, because this is some complicated here. That. So what are the formula of Cutter's equation, which is given V equals to 23 1 by n plus 0.00155 divided by 1 plus bracket 23 0.00155 divided by s bracket over n under root r into under root rs. Clear? So by this equation we find out bed slope. So in the red font, in equation A, in the red font this is neglect, means 0.00155 divided by s, which is neglect. Clear? So first of all, we have velocity, so put in this equation. So new term or new formula will be 23 plus 1 by n divided by 1 plus bracket 23 bracket over n under root r into rs. So put in this all this value in this equation, so we get bed slope, which is as 2.3 10 raised to minus 4. Done. So put in this value again in Cutter's equation. Done. So we get velocity 0.64 meter. So here, as per Kennedy's velocity and as per the final velocity, we just same. So the design will be okay. Done. So these are the method of Kennedy's theory. In the next lecture, we discuss about Lee's theory. Clear?